All righty. So it's asking for a question. Okay, in question number one, it's asking the data sets below are the quiz scores of randomly selected students from two different groups that were given the same statistics quiz. Okay, so yeah, group A, group B. All right, so there's a table below that's asking for the minimum, the maximum minus the minimum, which is the range. And it's asking for Q1, Q2, Q3. All right, so Q1 represents the 25th percentile. Q2 is 50th, which is really the median. Q3 is 75th. All right, so you may be asking, how do we get this? All right, so if you know how to do the median, remember those good old days of computing the median or getting the median? This is going to be helpful. So let's start with group A. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 values here. Okay, so it's odd. Odd meaning there's 9. Okay. So that means the median is going to be the one that has 4 below and 4 above. So 1, 2, 3, 4. Okay, that's 4 right there. 1, 2, 3, 4 above. All right, so the median is going to be 13. So you know that once you know the median is 13, you can put it in Q2, which is the median, 50th percentile. And might as well fill in the other ones too. You know, the minimum is going to be 6. Maximum is going to be 20. Might as well do group B. Minimum for group B is 12. Maximum is going to be for group B 22. And then it's asking for the range. So 20 minus 6, 14. 22 minus 12, 10. All right, so we got the range. All right, so here comes a little bit of a tricky part, but at least if you know how to get the median, you should be fine. Now, once I've identified the median, now I'm going to get the median of these set of numbers. All right, these set of numbers. So I'm going to get the median. To get Q1, you're going to get the median of these set of numbers. So as you can see, these are even numbers. There's even numbers there. Like when I say even numbers, like even set of numbers. So 6, 8, 10, 12, that's 4. That's an even number. So what you need to do is get the middle 2, add them together, divided by 2 to get the median for these. Let's see here. Keep going. So 10 plus 8, 18 divided by 2 equals 9. So you're going to get 9. All right. So you do the same thing for the top set. So you have 4 numbers there. 1, 2, 3, 4. You get the middle 2. Since it's even, you get the middle 2. 6, add them together, divided by 2. 16, 14, 3. Okay, so divided by 2. 17. Okay, so you got 17. Okay, I got those numbers. Now, to find Q1, Q2, Q3 for group B, let me start off by finding out what's the median for group B. So let's see, let me count the numbers. 1, 2, 3, 4, 5, 6, 7, 8. So there's an even set of numbers. So there's 4 below, 1, 2, 3, 4, 4 below, 4 above. Get the middle numbers, 17 plus 19 divided by 2. Divided by 2 is equals 16. 18. Okay. You know, it's 18. All right. So 18 is kind of like an artificial number there. So you already know that median is there. So you could just get these set of numbers and find the median from these set of numbers. And then those and these above one. And then those above 18, those above, and those below 18. Since there is an even set of numbers, so you get the middle two, add them together, divided by 2. Since they're both the same, it's going to be 15. So it's going to be Q1 is going to be 15. And then you do the same thing for the 4 numbers above. You got 19, 19, 20, 20, 22. I mean, 19, 19, 20, 22. Okay, so you get since it's even set of numbers as well, you get those 2 numbers, 19 plus 20, 39. 39 divided by 2 equals 19.5. All right, so that's how you do it. So it's all about getting the median. You just get the median multiple times. You get the median from the full set of numbers, and then you get the median from the bottom half. Remember, you exclude the median, all right, from the bottom half. All right, don't include the median. So you get the median from the bottom half numbers, then get the median from the top half numbers. Do the same thing, in this case, group B, get the median from the bottom half, the top half, and that's how you would get Q1 and Q3. Because if you get the median for the whole set of numbers, you already get Q2. All right, so that's how you would get these values. Any questions? So for no questions, okay, hopefully it's clear. All right, so calculate the interquartile range. So the interquartile range, well, before I start talking about interquartile range, you may ask, what's the point of this? What's the purpose? What's going on here? Why I have to learn so much about interquartile range, variance, standard deviation, etc. And let me tell you what's the point here. So what happens is that a lot of the data is skewed, all right? When you have extensively skewed data, standard deviation kind of gives you misleading results. The calculation of standard deviation, and we'll cover that right now in a few moments. I know it was already covered in the video, but so the purpose of even having interquartile range is to have a measurement of spread of numbers that it's not really it's not what I call it. It's not too much affected or sensitive to the skewness of the values. So when you have skewed distributions, interquartile range is the way to go. Okay, and then once you have the interquartile range, it gives you a sense of how the numbers are spread out, and you can compare it. You can compare with other skewed numbers. As long as you know the interquartile range for those set of numbers and this set of numbers, at least it tells you that this set of numbers is more spread out than these set of numbers. So that's kind of like the purpose behind this. It gives you a sense of how much the numbers vary from each other. So to answer group A, okay, so calculate the semi-interquartile range. So the formula to get first of all, you need to get the interquartile range first. So it's once you have your Q3, Q1 calculations or values, you can do it. So the formula is Q3 minus Q1. It's basically 75th percentile minus 25th percentile. That's what it is. All right, so once you do that, so in this case, group A is going to be 17 minus 9. 17 minus 9, what do you get? You get 8. Okay, so that's the interquartile range. There's one more step. One more step. Is asking for semi-interquartile range. Essentially, it's like the average of the those two sections, the one between the 50th to 75th percentile and the distance between the 25th to the 50th percentile. In honesty, I'm happy with interquartile range, but the assignment is asking for a semi-interquartile range, which is fine, fine, fine. All right. So all you need to do is divide it by 2, all right, to get the semi-interquartile range, and then you get 4. All right. Sometimes I'm happy with just interquartile range, but if you're asking for semi, okay, fine. Divided by 2, you get semi-interquartile range. All right. Now, group B, you basically do the same process what you did with group A. You get Q3 minus Q1. In this case, it's going to be 19.5 minus 15. So 19.5, oops, minus 15. You get 4.5. Okay, typically I'm just happy we're into interquartile range, which that's what it is. But no, it's asking for semi-interquartile range. Fine, let me do it. Simple. Divided by 2. You get 2.25. Okay. So the whole point of this exercise is to help you at least to compute how the numbers are spread out. And it gives you a sense of comparison. It's able to compare it allows you to compare the values now. And now we have created like an apples to apples comparison. So quick question to the class. Based on the semi-interquartile range, and remember, the higher the number, the more inconsistent, the more the numbers vary. All right. So group A has 4, group B has 2.25. Which set of numbers have more numbers that vary from each other? Put it in the chat. Group A or group B? All right, I'm seeing some answers. A lot of people are saying group A. That is right. Very good. So just to kind of reiterate, the higher the number, the more the numbers vary. In this case, I'm comparing semi-interquartile range, group A, group B. Group A has 4, group B has 2.25. So yeah, group A has more variety of data. Okay, there's some questions there that is asking. For each group, report the midpoint. Which group has the higher midpoint for the score? So the midpoint, remember, is Q2. So yeah, thank you, Elizabeth. So midpoint group A is 13, group B is 18, and so group B has the higher midpoint. All right. So remember, midpoint is the 50th percentile, which is right here. All right, for each group, which group has a wider spread of scores? And explain your answer. We already covered that. So in this case, it's going to be group A, because semi-IQR is higher. Okay, hopefully that makes sense. All right, question 2. Veterinarians looking at the weight of puppies from the same household in kilograms. What is the mean? All right, everybody, you do it. Your turn. 1 plus 2 plus 7 plus 7 total divided by 4. What do you get? Put it in the chat. All right, seeing some answers already. Thank you. All right, 4.25. Very good. All right, so what is the standard deviation? All right, calculated. All right. We'll do it the hard way, then later on I'll show you a shortcut. All right. But you got to pay your dues. You got to pay your dues. So we'll do the long way. Just for now. Just for now. Later on, we'll do the shortcut. Okay. All right. Don't struggle. Okay, so we write down the x's. One, okay, so right there, just write those down. 1, 2, 7, 7. All right, and then just add them together, you get 17. And then on the right, you just square them. Okay, square the 1 times 1, 1, 2 times 2, 4, 7 times 7, 49, and so on. And then you add them. You get 103. And then all you need to do is plug it in, plug it in. All right, so what you do is this one, you plug in there. And this one, you plug it in there. All right. So let me just rewrite it. And then the total number of values, which is 4, you plug it in there. And then there's 4 values. That's why I put 4 there. And then you plug it in there. So this one, so it's going to be 103. And then you get the square root. Okay, 103. Then 17 squared over 4 divided by 4. Remember to get the square root. All right, so 17 times 17, 289, divided by 4, 72.25, and then 103 minus 72.25, I get 30.75. Oops. So I'm done with this part. Divided by 4, then I get 7.6875. Okay, I'm not done yet. That is technically, once I do the stuff under the square root, that is what is known as the variance. Okay, this is the variance. But this one more step you have to do to get the standard deviation. To get that, you just square root 7.6875. Once you get the square root of that, you should get standard deviation equals 2.77. All righty. Hopefully that's clear. As long as you know the formula, as long as you know what to do with the x's, with the values, kind of like what I'm showing you, you can get it. Okay. Hopefully it's clear. All right, now what you do is so how do you interpret the standard deviation? So the sentence below says scores vary from the mean of, and then you plug in the mean, 4.25, average by, put the standard deviation here, oops, 2.77. All right, so scores vary from the mean of 4.25 on average by 2.77. So of the spread of numbers, most of the value spread on average 2.77. Hopefully that makes sense. All right, I'm gonna allow you to do number 3 on your own. All right, just remember, follow my guidance and complete number 3. Just you could always watch the videos or things like that, but just follow my guidance. I just want to make sure I cover everything else. All right, so number 4, use the given measurements for groups A, B, and C and answer the following questions. So the purpose of these questions is for you to know what the symbols mean. So X bar, I don't know what's an easy way to remember, but X bar means the mean. They mean mean. I'm not mean. I'm not mean by telling you that it means mean. I'm just saying it means mean. Hopefully that makes sense. All right, and I'm not mean about it. All right, the S stands for standard deviation. Surprised nobody's laughing. These are great. This is great material. I rehearsed over and over, but it's okay. S stands for standard deviation. So when you see Superman flying, see that S? It doesn't mean Superman. It means standard deviation. All right. So go watch Superman and correct people when they say that's Superman. No, that's standard deviation, man. Standard deviation, man. Why do you say that? Because he's wearing an S on this suit. Standard deviation. All right. So thank you, Brian. All right. So X bar means mean. Standard deviation means, okay, S stands for standard deviation. All right. So list the groups in order from lowest mean to the highest mean. All right. Thank you, Emily. All right. So what you need to do is, knowing that X bar means the mean, you got to put them in order. So it looks like, because of my writing, I covered it up. There we go. Okay, so group A has the lowest mean. So group A, the second one is group C, the third one is group B. Let me check my answers. Yeah, I got it right. Okay, good. I have the answer queue just to make sure I'm doing it right. Okay, so I put them in order. Okay, so standard deviation in order. So list the groups in order from the lowest variability to the highest variability. Okay, so standard deviation with the highest variability is group C, because 3.2 is higher. And then group A is the second highest. And then group B is the lowest. And that spells cab. I think I messed up. I messed up. I'm so sorry. I messed up. I did it on purpose. I wanted to make sure you're all paying attention. Apparently, nobody corrected me. It tells me nobody's paying attention. So the lowest is group B. Look at that number. The lowest is group B, 1.25. The second lowest, thank you. The second lowest is group A, gets 2.5, and then the highest is C. And that stands for back. So don't go in a cab. Stay lying on your back. I don't know. Trying bad joke. All right. Anyway, I'm stretching my jokes here. All right. So what is the 68%, 95, and 99.7 range for group A? Oh gosh. Okay, here we go. So it's all based on the distribution of scores. So just remember that the mean is always in the middle. All right, so the mean, and then here is one standard deviation below the mean, two standard deviations below the mean, three standard deviations below the mean. And this is one standard deviation above the mean, two standard deviations above the mean, three standard deviations above the mean. And I'll show you what that means. I'm saying, for every time I say mean, you all get a nickel. All right, so the mean for group A is 6. All right, 6. All right, so that's a mean. And you know the standard deviation for group A, 2.5. Okay, so once you know the mean and the standard deviation, you can get these. Okay, so from here to here, let me get a different color. This is 68%. From here to here, it's 95. And then from here to here, that's going to be 99.7%. Okay, now it's asking for the range. Let me show you how to do that. So you know the mean is 6, not, okay, for this distribution, the mean is 6. So you know that from one standard deviation below, one standard deviation above the mean, you get 68%. So what you do is you add one time 2.5 to 6. So that gives you 78.5. So so you add one standard deviation, which is you add 2.5, and that gives you 8.5. Okay, so now you subtract one standard deviation from the mean, and that will give you 3.5. So the range, the 68% range, is going to be 3.5 to 8.5. Okay, if you follow that logic, you can do the other ones, but it's just a little bit different, all right? So to get the 95% range, you add 2 standard deviations to the mean. So okay, so I already know that if I added 1 standard deviation to the mean, I got 8.5, okay? But I'm going to add another one. I'm going to add another standard deviation, which is another 2.5 right there. Sorry for my writing. Gosh, that's awful. Nobody's complaining about it. I'm surprised. Like, gosh, professor, that writing's awful. You should really practice. And I'm like, okay, I will. Give me a moment. I'll do it over the weekend. Okay, so you add another 2.5. Okay, so you add 2 standard deviations, like adding 2.5, 2.5. Okay, and then you get 11. You get 11. And this time, okay, but you kind of do the other way around. So this time you subtract 2.5 twice from 6. So you got, okay, so 3.5, and then you subtract another 2.5, you subtract it, and then you get 1. So the range is going to be 1 to 11. All right, now to get the 99.7 range, you do it 3 times. You add 2.5 3 times, in this case, 3 standard deviations to 6, and then you subtract it 3 times from 6. So you do that at 2.5, 2.5, another 2.5, and then you get 13.5. All right, so that's 13.5. And this time you subtract it 3 times to get the bottom part. To subtract 2.5, another 2.5, subtract another 2.5, and you get negative 1.5. So you get negative 1.5 to 13.5. This is the 97.7 range. Okay, so I have the 68% range, the 95% range, and the 99.7 range. That's how I'm able to get those ranges using what we call the empirical rule. All right, hopefully that makes sense. So here it kind of gives it to you a little bit much more clearly. All right, let's see. Let me see if I could skip this here. So yeah, so if you can fill this out, actually, it just makes more sense. Like for group B, the group B is 10.5. The mean is 10.5. So, okay, so I just did group A, all right? Group A, I add 2.5, you get 8.5. Add another 2.5, which is the standard deviation, becomes 11. I add another 2.5, it becomes 13.5. Add another 2.5, it becomes 16. Okay, to get the bottom one, you subtract 2.5, which is 2.5 is the standard deviation. So you go 3.5, you subtract another 2.5, which is 1. You subtract another 2.5, negative 1.5. You subtract another 2.5, you get negative 4. Okay, so group B has a different mean and different standard deviation. It's not always 2.5, okay? So don't get confused. So this one is going to be standard deviation is going to be 1.25. Okay, group B has standard deviation of 1.25. So I'm going to add 1.25 to go to the upper end and subtract 1.25s on the bottom end. So I add 1.25 to 10 one time. I get 11.75. I add another 1.25. It gives me 13. Another one, it gives me 14.25. And then I add another 1.25. It gives me 15.5. Okay. Anything above the mean, you add. Anything below the mean, you subtract. And then on this one, I'm going to subtract 9.25. Subtract 1.25 from the mean. And then subtract another one, you get 8. You subtract it again, 6.75. And then you subtract it again, you get 5.5. So, and that's why, look, you see the 68% range, 3.5 to 8.5, is right there. That's what I have here. The 95% range, 1 to 11, 1 to 11, it's right there. The 99.7 range, negative 1.5 to 13.5, it's right there. All right, so, and then you could just answer the questions. I'm just going to answer one because we're running out of time. Looking at group A, what percentage of data falls between 2.5? All right, 2.5, where's 2.5? Did I mess up? And 8.5. So 2.5 is going to be somewhere in the middle. Let me see. Let's see. Oh no, it's a typo. It's a typo. All right. It should be 3.5. All right. Yeah, I think you're right. But this should be 3.5. We're not making life harder here. Not yet. We won't be calculating that yet. Okay. It's a typo. I'm looking at another copy of it. All right. So for those of you who have it, make sure you put it 3.5. Okay. 3.5 to 8.5. So the percentage of that, okay, what's the Gerger? What percentage fall? Okay, a data fall. It'd be 68%. So 3.5 to 8.5, it should be 68%. So looking at group B, which data falls between what values? What's 99.7%? So I'll do this one too. I'll help you out. So you want to look at 99.7% for group B, and it goes here. So it's going to be these. It's going to be this one. Let's see. 6.75 to 14.25. 6.75 to 14.25. All right, just want to make sure. I look up because I want to make sure I'm telling you the right answer. Sometimes I get so distracted. All right, so hopefully that makes sense. Do this one. Well, I think I already helped you do this one already, but make sure you complete it. Make sure you also do this on your own, since I already gave you an example of how to do the standard deviation, and we'll keep learning how to do all these calculations. All right, I'm out of time. Thank you for hanging in there. You're troopers. Enjoy the rest of your evening and go Dodgers. All right.